So this is Rapidform XOR 3, and the model we're looking at on the screen is the point cloud generated from the Focus3D scanner. Now this point cloud is approximately 67 million points, and we're able to navigate through this data fairly easily on this laptop because of Rapidform's new out-of-core memory architecture. You'll see if I bring up the task manager that Rapidform is only using just over 100 megabytes of memory as opposed to gigabytes of memory if we dumped all of the data into the memory core all at once. So we have a unique memory architecture that allows us to work with hundreds of millions and even billions of points when we're processing. So this is our standard object view, but we can also change to a walkthrough view, which will allow me to sort of just walk through the model interactively. Again, here we're seeing a closer look at the point cloud and the scanning. And now I'll turn on some of the CAD data that we reverse engineered from the scan data. And then we'll hide the point cloud for a moment just to see what we did. So our task was to create an as-built model from the scan data that would be used for downstream operations. And you can tell from how some of these beams don't exactly line up to one another that we have tried to really capture exactly what was built, as opposed to a design intent model where surfaces would be parallel or forced to be perpendicular. But in this model we constructed the as-built conditions. Now we modeled a fair amount of the boat, not the entire thing, but of this particular part of the bridge, so we can see beams on the ceiling and the walls. Now the floor and the ceiling are also cambered, so they are not perfectly flat surfaces, and we tried to do a good job in capturing that. And when we look at the data simultaneously with the point cloud, you can see a good matchup between where the point cloud was and where the model was created. Now to get a better sense of the accuracy, we can use our accuracy analyzer, and I'm going to switch this on to color map mode. Okay, here are the deviations shown in the model. I've given an allowable tolerance of plus or minus a quarter of an inch. So everything shown in green falls within that tolerance. And we've got pretty good results on most of the walls and the beams all around this area, even all the way to the back. We're within a quarter of an inch. And as we start to see blue areas and orange and red areas, those are where we're getting slightly higher deviations. As I mentioned before, the floor and the ceiling are cambered, and the model that we've created is a fairly simple camber of a single arc for the entire vessel. So it's understandable that we see deviations on the floor and ceiling, as it wasn't a maintained perfect arc throughout all the floor and ceiling areas. Okay, so we created this feature-based model inside of Rapidform XOR, and from here we can save it as an IGES or step file to go directly to a lot of other packages. But we can also use our live transfer function to go directly on a feature-by-feature basis to SolidWorks, Siemens NX, and Pro Engineer. And that's what we did to create this SolidWorks model. So here we see the same feature-based model reproduced inside of SolidWorks, and you'll see if I switch to a section mode and I sort of hide the ceiling for a moment, that we have all of the internal structure and beams and everything else here inside of our SolidWorks model, and we can now work and continue on in this model in SolidWorks to do a lot of interesting things. So back to XOR for a moment. We can also examine how was this model produced, because we have an entire feature tree that we can step back through. So I'll roll back the feature tree to the very beginning, and here we have various sketches that have been created. And the first surface of the ceiling, followed by the surface of the floor. Again, both created as sweeps to produce a camber for those regions. Stepping through to extrude the walls upward and then intersect them with the surface we made at the top and the bottom. Again, starting to do some additional thickening and Boolean operations, and then many extrusions of walls of data to create beams off the wall, to create I-beams throughout the model. Here's that sketch that was created for those beams, which then got extruded. So here you can see all the I-beams that are going to be along the ceiling of the model. And we can just jump all the way to the end as the entire model was produced in this manner. Now, one of the questions we were asked yesterday was, can we offer just the surface of the floor to be able to use that for layout things downstream? So we can do that. I selected the surface, and I'll just say insert surface offset, and offset the surface by a value of 0, which will essentially give me a copy of that surface. And I'll just hide the CAD model and show the surface model. So now we have that surface was showing cutouts where all the beams were along the walls, as well as where some of the support beams were in the back. So we can do that fairly easily. Okay, that's it for this video. Again, my name is Dave Bell at Rapidform. Feel free to contact me at daveb@rapidform.com if you have any other questions. Thank you.